Hey all, hope you are doing great. In this video, we are going to deep dive into change detection. Change detection, which is one of the most important question being asked in interview. So stay tuned till the end of this video. We are going to do some interesting experiments and that will clear your doubts about change detection. We are going to get answer some of the questions like what it is, why it is super important, does it really impact performance of a web application, how does it work, what triggers change detection, why it should be handled carefully. We will have a live demo and gradually we will improve our application. But before that, let's have a quick glimpse of our application. So in this application, we can see we have a few buttons, one checkbox, which are placed on app component. So if I click on this button, you can see the number are getting changed. If I hover on this, again the number are getting changed. If I click on get to do Ajax, so I'm getting a response from uh, HTTP call. If I look into the developer tool and go to the network tab and click on this again, you can see that I'm getting some response from the server, right? So we need to understand like what is happening behind the scene and is it really feasible to uh, if these numbers are changed, what does it mean? If I start the interval, you will also see that after 2 seconds the numbers are again getting changed. And if you are wondering how these numbers are coming, so is so it's nothing but an expression. Here into this expression I'm calling a check view, and whereas check view returns an counter. If you see here, so we will gradually improve this application and we'll try to identify what problems this application, right, and how we can fix it. So ultimately we will be improving the application performance. But before we jump into all this stuff, all this technical details, we need to understand what is change detection. All right. So it is the process of updating or re-rendering the DOM to reflect the new state of the data model. In AngularJS, it has $scope.apply, $scope.digest. In React, we have set state. In Angular, we have ngZone and Zone.js. Now, what triggers change detection and how does it work? So suppose we have an interface. An interface, from interface we can click, we can mouse over, we can key up. So all the browser events, and apart from browser events, set timeout and set interval also trigger change detection, as well as HTTP request. So all the Ajax call which connects to our backend server, and when the data will come back, it will try to update the, it should actually logically it should get updated to the UI. So on that particular time it triggers change detection and it update the UI. So this is how it works. So let's see change detection in action. So in our application, the moment I click on click me, I'm getting a message on the UI, right? We have a button. On click, we are calling a function test, and test actually setting a message, and this message variable is a class level variable. That what I am using here as a interpolation, right? So this is how the variable has been binded to my UI, right? So the moment I click on this, I'm getting this message. So on clicking, the change detection gets triggered and it's update the UI. So this is an example of change detection in Angular. Now let's try to understand what different issues we have in this application. Here you can see we have a header component which nothing which only renders static text, whereas our image component only renders image. So if I perform any action on this browser, every change detection gets triggered. So I'll explain a bit later that how the change detection tree get constructed and how does it work. So just wait for a few while. Now you observe that everything is getting updated, which is not a good thing, because in header we are not changing anything, right? It's a static text, whereas in image component the image source is not going to change. So what we need to do, we need to somehow stop this. So before we jump into the code, let's first of all try to understand how each component are associated with its own change detector. All right, so in this presentation you can see each component in Angular has its own change detector. It's 1:1 ratio. So in our application we have 4 components, so it will have 4 change detector. As we all know, the Angular application is a tree of components. So for each component in the tree, we have an associated change detector created at application startup. So this is how it looks like. So uh, now you can see header component and image component are not going to change. So what we need to do is we need to detach this from this change detection mechanism. So how we can do it? Let's jump into the code. Okay, this is our image components. So let's detach this component from change direction. So first of all, we need to inject a reference. I'll name it CD change detection detector reference here. Now I need to call this .cd .detach. That's it. Save it and go to the browser. Now if I click me, hover me, you see this component is not getting updated. All right, so in the similar way I'll update header component as well, because we are not going to change the header text. So I have updated header component as well in the similar fashion. Now you see header component is not changing. In this way we can see we have improved our Angular application performance to great extent, and we must detach all those components which are not going to change, so they won't be part of change detection. So we have seen how Angular creates a change detector tree, how each component associated with change detector, but behind the scene what actually it does. Let's look into this code snippet. JavaScript, the whole runtime is overridden by design. Angular will replace add event listener with a new version that does the equivalent of this. The new version of add event listener adds more functionality to any event handler. Not only the registered callback is called, but Angular is given a chance to run change detection and update the UI. This low-level patching of browser API is done by a library shipped with Angular called Zone.js. A Zone.js is nothing more than an execution context that survives multiple JavaScript VM execution turns. Angular uses Zone.js internally to trigger change detection. If you would like to explore Zone.js, here is the link. I will put this link into description section as well. Okay, enough theory. Let's do some more interesting practicals. So types of change detector in Angular we have default and OnPush. So let's implement them. So in any component, if we in component decorator, if we type change detection, then it provides us two strategy: default and OnPush. All right. So if you do not mention, it will pick default one. So there is a no need to mention default strategy. So let's remove it, save it. So what I am doing with this component, I'm getting data as an input in input variable, right? And then rendering with a li. Here you can see. Okay, let's go to its parent component. So our app.component is the parent component of app data. Here you can see at line number 35, we have this component and we are passing user array. So let's see what is user array. So if I switch to TS file, we will see that we have a user array here. We are initializing this array and pushing some names like user 1, 2, 3, 4. All right. And there is a method also which actually puts a user into it. And this method is being called uh, from the HTML. Here you can see in app.component.html there is a button which calls this function add user. All right. So let's go into the browser. It has rendered all the 4 users, and the moment I click on add user, so the change detection also triggered for this component and change detector of app component as well. All right. Now let's make some interesting changes and see what happens. So I am into the app data.component.ts. Here, if I change the change detection strategy to on push, and go to the browser again and click on add user, you will realize that it's not working. The change detection of our app data is not triggering, whereas app component is still working, but this is not working. So what's wrong with this? Let's try to find out. So let's try to identify what's wrong with this code. Here you can see into the constructor we are initializing an array and then we are pushing 4 users. On the add user we are actually pushing a new user. So on push strategy works only when the reference get changed. So what we need to do, we need to create a new reference, and that can be done with mutable.js as well. All right, so there are various ways to make a new reference you can explore on the wave. So let me do one thing. Let me copy this, paste it here, and try this again. Now if I try to click on add user, you see now we can see the data. If I click on again, so there is a no change on the data side, because every time we are what we are doing, we are actually passing the same set of data. All right, but you see this count is getting increased every time. So what is the catch here? The catch is if we change the reference, our on push strategy will work, right? So let's see how we can use this functionality to make our application more performant. All right, so what we will do, we are going to implement a http request and see how does it work and what are the different aspect we can understand from it. Okay, so now my app component actually get data from this url, right? So I'll show you the code here. So our get to do actually hit a server url here and subscribe to and get data. To do data is being passed into the child component. Here you can see it. All right, so how we can use this? So what are the use cases? So use case is, let's jump into the browser again. So logically what should happen? So let me reload it. If I click on get to do, so it should reflect here, right? Every time if I get successful result, it should reflect here, right? And change detection, you know change detection gets triggers on that time only. But what if there is a error? Do you think that it should trigger the change detection of this child component? Because we are getting error, there is a no need to update the ui, there is a no successful result, right? So let's make some changes and generate the error and see if the change detection is getting triggered in case when there is error. So what I'll do, I'll just change this URL, like I do something like this and save it. So I'm again on the browser. If I click on here, you see the change detection is getting triggered. So what I did, I'm using the default change detection strategy. But if I change this to on push, save it, and go to the browser again. Like if you go to the network tab and see here, if I click on this, you'll see that we are not getting results, and my change detection also not triggering. So this is the correct use case that what we are willing to achieve, right? But if it is successful, it should get triggered. So let's revert the changes on the service URL. So I'll just revert the changes, save it, and we'll go back to the browser again and try it. You see, so if there is a success, our change detection is working fine. If there is an error, it is not triggering, so which is actually improving our application performance. All right. So if we concentrate at line number 25, we can see that what is happening. Actually, every time whenever we are getting successful response from the service, we are actually initializing a new object, which is a new reference, and that's why our on push is working. So the next second part would be error here, and that we can handle here. So we can toast a message so that user will come to know, okay, there is error. So this is the right use case, and this is the correct way to use the change detection strategy. We have default and on push. So what are the takeaways from this session? Presentational components, which represents static text or images whose sources are not going to change dynamically, they must detach from the change detection. Smart components which gets data from its parent, they must implement on push change detection strategy. All right. Thanks for your precious time. Stay tuned for more technical videos. Do subscribe and share with your friends and colleagues. This gives me a great motivation. Thank you.